made that day. So it says I made $28.25. Well, how do I come up with what I make every day? It's going to be based on my base daily rate plus the number of cakes I made times 75. So I'm just going to make an equation for that. $12 plus 75 cents per cake. Per means to multiply. So we don't know how many cakes I made. That's what we're looking for. So we're just going to use that variable of C to tell how many cakes, or to determine how many cakes I made. Now we have a basic equation we need to solve for our variable. First thing I'm going to do, I'm still going to divide my paper. And I don't have that much room, so I'm going to try to write small. I normally write big. So we're going to say minus 12 on both sides. So now we have $28.25 minus 12, which will give us $16.25. And we only have 75 cents times C on this side. Now to get that variable by itself, we're going to have to divide by 75 cents. This will cancel out. We only have the variable C left on that side. And we have 21.6 repeated. Now there's no way that I could have made a portion of a cake. So if you round that up to 22, that will be fine. So your answer here is 22C. $22 cakes. The next problem that we will be doing will be number 9. Number 9 says to solve this equation. Oops. It's too big. Let me back that up. Okay, maybe this will work. Yeah, that'll work. So number 9. Negative 6 plus x over 4 equals negative 5. We're going to do the same thing that I did previously, which was divide my equal sign. I don't have any like terms on one particular side of the equal sign. Negative 6 plus x over 4 are not like terms, so I can't add those. The negative 5 is by itself. So I'm going to move my number that is not attached to my variable. So I'm going to add 6 on both sides. This is negative 6, so we need to say plus 6 on both sides. This will cancel out. Negative 5 plus 6 will give us 1. Got to keep up with my equal sign. And then I'm going to bring what I have left down. Now this number here is where a lot of students get, this is the part where a lot of students get confused. X over 4 is a fraction. When you divide by a fraction, you are actually simply multiplying by the reciprocal. So I'm going to show you all how to do that. Wish I had more colors. Let's see. Oh, that's not going to go. So I'm going to multiply on both sides by the reciprocal. Reciprocal means you're just simply flipping your fraction. This will cancel out. I will only have x remaining. And 4 times 1 would give us 4. 1 times 1 will give us 1. Any number over itself is over 1 is just that number. Let me repeat that. Any number over 1 is just that number. So here x is equal to 4. That's your answer. Not too many steps. Very simple. That's number 9. The next one will be number 11. And I'm trying to work some that have fractions on it. I know a lot of you guys are scared of fractions. Number 11. One half plus 4x equals negative x plus 2. What am I going to do first? Yep, you're absolutely right. I'm going to divide my equation. Okay. Do I have like terms on both sides? On like one particular side? Let's say that on one particular side. No, 1/2 and 4x are not like terms. So look to the other side. Negative x plus 2, that's not like terms. So now I'm going to move my number and get all my numbers on one side. So 1/2 is positive, so we're going to make it negative by saying minus 1/2. We're going to do the same thing on both sides. That will cancel out. 2 plus negative 1/2 will give us 3 over 2, or 1 and 1/2. It's the same thing. If you're using a calculator, you could have kept the 1 and 1/2. I'm going to stick with 3 over 2 because I'm not using a calculator. And then I'm going to bring down what I have left on this side, which is 4x and my equal. And then I also had negative x over here. Don't forget your signs. I know it's easy to do. I sometimes do it myself. So now we're going to plus our x on both sides because we want to try to get everything with their like terms. Okay, so now we have 5x is equal to 3 over 2. Now, how are we going to get that 5 away from that x? You're absolutely right. We're going to divide. Now, if you put in your handy-dandy calculator, 3 over 2 divided by 5, that will give us x equals 3 over 10. I hope everyone can see this. If not, I'm just going to draw an arrow up here and write it again. X is equal to 3 over 10. All right, that one looks good. We're going to go to another problem. Our next problem will be number 14. Number 14. Number 14 is a longer problem, but we can do it as well. X plus 5 minus 2x equals 4 plus 4x minus, plus 1. Plus 1, my bad, sorry. I'm going to do the same thing, which is, yeah, you're right, split my equation. Now I'm going to look for like terms on each side of the equal sign. Look like we may have some. Let's see. We have a 6x right here. And we have a negative 2x right here. All right. On this side, we have 4 and we have 1. So we do have quite a few like terms. That's number 2 on our steps. So 6x minus 2x will give us 4x. We're going to bring what we have left down, which is plus 5. Yeah, don't forget your equal sign. 4 plus 1 will give us 5. We're going to bring what we have remaining, which is our 4x. Now we need to get all of our variables on one side. So I'm going to subtract 4 from both sides. Ooh, look what we have here. There's a plus, there's a minus. That's going to cancel out. Yeah, you're absolutely right. Now think about it. 4x minus 4x. If we say 4x minus 4x, how many x's are we going to have left? None. So that's going to cancel out as well. Now we're going to bring down what we have left. 5 equals 5. Now, in this particular problem, we're trying to determine, do we have a solution, no solution, or infinitely many solutions? 5 equals 5 is a true statement. So if you go back to your first page where you have your notes, this is true. So that means we have infinitely many solutions. This is true, so that means infinitely many solutions. You notice we only did 2 steps. We combined our like terms that were on one side of the equal sign, and then we looked on the other side and we combined our like terms that were over on that side. Then we got our variables together, and then we just simply brought down what was remaining. So that's all you have to do on that problem. Have about 7 problems. Hopefully we can wrap this up pretty quickly. Next problem will be number 15. We're also trying to determine if we have many solutions over on this side as well. I'll make this just a tad bit bigger. Okay. Right now, just a little bit. Okay. Number 15. That's not going to work. Let's make that up. Went too far back. Okay, let's try this again. Number 15. (6x minus 3x plus 8 equals 16. Now, some of the students got a little tricked up on this one today. Whenever there's a negative sign or a positive sign outside of your parentheses, just put your imaginary 1 right there. Now you can do your distributive property. Just imaginary 1. Okay. So now we have -1 times +3, which will give us a -3x. -1 plus, -1 times a +8 will give us a -8. Then we want to make sure that we bring everything else down. This is a negative. So let's go back through that one more time. Beside our negative sign in our original problem, we added a 1. We did distributive property. Then we brought everything else down. Just pretty much 2 steps, adding a 1 and doing distributive property. Now I'm going to go back because I forgot to do what? Yeah, you're absolutely right. I did not divide my equation. So now we want to see, do we have like terms on either side? Well, let's see. Yeah, there's an x here. And look, there's another one right here. All right, so 6x minus 3x will give us 3x. Bring everything else down. Just break it down. Keep it together. We don't want to leave anything behind. And bring it all the way down. Now we need to get our x by itself. So we're going to say